Here in question 9 from chapter 15, Open Stax, we're asked to write some equations and then write some expressions for the KSP. So let's go ahead and do that. So for lanthanum 3 fluoride, we've got a solid that's in equilibrium with lanthanum 3. Okay. Aqueous. And there are 3 fluorides. Fluoride is in the halogens where those ions have a -1 charge. Calcium carbonate. Oh, I forgot to write the KSP. KSP here would be equal to the lanthanum concentration times fluoride ion concentration. Okay, and since we have a 3 there, this would be cubed. Okay. Calcium carbonate is in equilibrium with calcium, which is a group 2 element, and carbonate, which is a commonly occurring polyatomic ion. We would write KSP here is equal to calcium ion times carbonate ion. Okay. For part C, we've got silver sulfate, solid, in equilibrium with 2 silver ions. Okay. And sulfate, which is a polyatomic ion. And the KSP for that is equal to the silver ion concentration squared times a sulfate ion. Okay. A lot of students get confused. Why does the 4 stay with the oxygen there, but the 2 does not? And you keep the numbers for the polyatomics, but you know, the subscripts for the polyatomics, because that's part of the identity of that ion. But the 2 is not, the silver ion is not a polyatomic ion. For part D, we've got lead 2 hydroxide. Lead 2 hydroxide. And we draw the equilibrium arrows there. And this is in equilibrium with lead 2 ion, which is aqueous, and hydroxide ions, which are also aqueous. Okay, so we got 2 hydroxides, and each of these is -1, so a -2 charge there tells us that the lead is a +2. The KSP for this is going to be equal to the lead 2 ion concentration times hydroxide ion concentration